Hi everyone. In this lecture, we will talk about stable and unstable systems. Okay. So basically, to understand this concept, you should know about the bounded signals. So what do we mean by bounded signal? So a bounded signal has a finite magnitude denoted by mod of x of n smaller than equal to m. Means a bounded signal has a finite magnitude. It should not have infinite value. Okay, it should always have a finite value. It is clear? Fine. Now the value of m is what? A positive real finite number. Clear? And the perfect example of a bounded signal is what? A sine wave. So basically, this is what a short definition of a bounded signal, that it should have a finite magnitude denoted by this particular expression. Fine, where m is what? A positive real finite number. We'll see more, don't worry about that. So basically, what is BIBO? So BIBO means what? Bounded input, bounded output, stability. This refers to a system where every bounded input produces a bounded output. Clear? So a system is said to be BIBO stable if and only if every bounded input produces a bounded output. Then we can say that a system is what? Stable system. Is it clear? So suppose x of n, this x of n is what? This is basically input, right? Input to what? Input of discrete time system. And y of n is what? The response or the output. Okay, output for what? X of n. Hope it is clear to you. Fine. Now let's move further and understand these terms like bounded input and bounded output. These two terms you should aware, right? So what is bounded input? So bounded input refers to a finite value of input signal x of n for any value of n. It is simple, straightforward. Fine. So basically, if the input x of n is bounded, then there exists a constant mx such that what? Mod of x of n should be what? Smaller than equal to mx, and this mx is what? It should be smaller than infinity for all values of n. So you should aware about this condition. This is what the bounded input. Fine. Now examples of bounded input signal include what? Step signal, decaying exponential signal and impulse signal. Whereas if you go for the examples of unbounded input signals, so ramp signal, increasing exponential signals are few of the examples. Hope it is clear to you. Fine. Now let's move further and understand the term bounded output. Same. See, bounded output refers to a finite and predictable output for any value of n. So if the output y of n is what? Bounded, there exists a constant my such that what? Mod of y of n should be smaller than equal to m of y, my, right? And this my should be what? Smaller than infinity for all n. So hope it is clear to you what is bounded input and what is bounded output and what are the conditions for that. Fine. Now let's move further and understand few more things like, okay, so let the input signal x of n be bounded, means finite. So if the input signal x of n is what? Bounded, that means what? So basically it means it means mod x of n is smaller than equal to mx, right? And this mx is what? Is smaller than infinity. For what? For all n, right? For all n, where this mx is what? This mx is basically a positive real number. So if in this case, if you will get mod y of n, which is basically what? Output is smaller than equal to my, and this my is what? Smaller than infinity for all n, then in this case, so if the output is also bounded, so if you apply the input signal which is bounded and you got the output also bounded, it means what? It means the system is BIBO stable. System is what? BIBO stable. Hope it is clear to you. Fine. Now, the stability of a system is determined by applying specific inputs and observing if the output remains bounded. So this is the condition. I applied the input signal which is bounded, and if I will get the bounded output also, so I can say the system is what? BIBO stable system. Fine. In the next lecture, we will see the condition for stability of LTI system, in which we are going to apply a bounded input, which is basically what? A impulse, right? So what we will do? We will apply the unit impulse signal and we will check the response. So that will cover in the next lecture. Don't worry. So thanks for watching this video. If you have any doubt, you can ask in the comment section. And don't forget to subscribe to our YouTube channel.